Hello and welcome to PCMINR.com, and you're watching this video on Archimedes principle by Sonal Gupta. Now before we discuss anything about Archimedes principle, I want to tell you to think about an observation which you might have done in your daily life. Like if you have an iron needle or an iron nail, a small iron nail, it will, you see, just goes down and floats in water like you can see here. But a big ship of iron, it floats on the surface of water. Now what makes this possible? So this phenomenon, we can say, or this application of Archimedes principle helps us to predict this possibility of a ship to float on water. So actually what happened, like many years ago, a Greek mathematician Archimedes, he observed that both a body and water in a container cannot occupy the same space simultaneously, which means that if you immerse an object, like here we see there's water stored in a container, if you immerse an object in the container of water, the water has to flow out, right? So if it is filled up to the brim, the water starts falling out. Now here some part of it has been immersed, and here you see that the entire block is immersed inside, and the amount of water that has flown out collected here is more than this level, right? So it means that when we immerse a body in water, some water is displaced to make the space for the body. And Archimedes found that the volume of water displaced, or the amount of water displaced, the volume of water that has been displaced, it depends on the volume of the object immersed. So that is equal to the volume of object immersed, which obviously means that a bigger body will displace more water than a smaller one. And further, the amount of water or the volume of water displaced determines whether your object is going to fall down, sink to the bottom, or it will float on the surface. So based on the volume of water, how much water has been displaced, we find out, or we say this factor is responsible for the floating of big ships and the sinking of small iron needle, because as you can see that a big ship, its volume is large, so it displaces a large amount of water. You can see here, if you or this small nail could not displace that big amount of water, so it sank to the bottom. But something that displaces more water, we would say it floats on the surface of water. And displacement of water you might have also observed while swimming, because when you are pushing the water with your arms, you're basically displacing water from there to create a space for yourself, and you try to displace more and more water. So now let's determine the relationship of the water displaced and with the volume of the body mathematically, and also find out how the things float and how the things sink. So we see here, like we just took a body which is immersed in water. You can ignore the mass, we don't need it here. So this has water on the top surface of it, and there's water below it. So there is one pressure acting on the top surface, which is P1, and one pressure acting at the bottom surface, which is P2. And since we know that the pressure, the formula is H rho G, so I will write P1 is H1 rho G, because this is the height H1. So the top surface of the body is at a height H1 below the surface, and the bottom surface of the body is at a height H2 below the surface. And since these two heights are different, though the density of water is same, G would be same, but the heights are different. Therefore, there is a difference in the pressures at the 2 points. So we would say, therefore, the difference in the pressures, that gives us equal to P2 minus P1, because we know that P2 would be greater as it varies with depth. So the pressure at the bottom of the body is going to be more than the pressure at the top of the body. So P2 minus P1, and that gives me H2 minus H1 times rho g. So this gives us the net pressure acting, and of course this is the net pressure acting in the upward direction because P2 is greater. This net pressure which acts in the upward direction gives rise to a force in the upward direction. We would say pressure, forces pressure into area. So this net pressure acting in the upward direction multiplied by area gives us a force which I would call as the upward force. And that upward force is a force of buoyancy. So you can denote it by FB also, or we sometimes use the letter U to denote the upthrust. So upthrust and force of buoyancy are two same things. So that is equal to P net into A, which means H2 minus H1 rho G into A. If we consider this H2 minus H1 be the total height of the object to be H, so I would write this is equal to AH rho G. And what is AH? Area into height is the volume of the object. Therefore, upthrust is equal to the volume of the object into density of water into G. So we find that the force of buoyancy, or the upward force that is acting on the object, which is pushing the object upwards, is equal to V rho G or mg. That is equal to the weight of water displaced. Now we find that upthrust, or the force of buoyancy, is equal to the mg, the weight of water displaced. Now that is what Archimedes' principle says. So principle states that when an object is immersed in a liquid, like here we have an object, it is immersed in a liquid, it experiences an upthrust, right? It experiences an upthrust, and that upthrust is equal to the weight of water displaced, which we have proved mathematically that it comes out to be equal to m times g. So Archimedes' principle can be stated that when an object is immersed in a liquid, it experiences an upward force called the upthrust or buoyancy, and this upthrust is equal to the weight of water displaced by the object. So whatever amount of water has been displaced by the object, based on that you receive an upthrust. Now obviously, since upthrust is equal to the weight of the object, weight of the water displaced, or it is equal to V rho G, the volume of water displaced, it means for a larger volume, right, for a larger volume, the water displaced would be more, and since water displaced would be more, therefore we can say that it would be more, therefore the upthrust would also be more, because upthrust is dependent on the volume of the water displaced, and a larger object will displace more water, so it will receive a greater upthrust. And so based on the amount of upthrust, we can determine whether an object will float or sink. So if your upthrust is greater than the weight of object, that is weight of water displaced or the liquid displaced is more than the weight of the object, right, that's the weight of the object, then obviously the object would float on the surface because it is receiving a greater upthrust. So upthrust is more and the weight acting downwards is less. So we can say here the two forces acting, upthrust upwards and the weight downwards. So if upthrust is greater than the weight, obviously it receives a more upthrust, means an upward force, and so the object would float. But if upthrust is less than the weight of object, that is if the weight of water displaced, right, weight of water displaced is less than the weight of object, the object will sink, right. So weight of the object is more, which is acting downwards, and weight of water displaced or upthrust is less, so the object would sink down. So that is why an iron nail which has more weight and less volume. So volume being less, it receives a lesser upthrust, and weight is greater, so it sinks to the bottom. Whereas a huge ship whose weight is big enough but its upthrust is even greater than the weight of the ship, because its volume is large, and because of the large volume it receives a large upthrust, and so it is able to float on the surface. I hope Archimedes principle and its application is clear to you. Keep watching, and if you like our videos, please follow us, like us, subscribe us, and follow us on Instagram and Facebook at PCMINR.com. Thank you.